So we know that end behavior works the same for even degree polynomials, and it works the same for odd degree polynomials. So the nice thing is we know what quadratics look like, right? And those are even degree. And we know what lines look like, and those are odd degree. So then it's pretty easy to determine end behavior. So we look up here, and you guys said it was an even degree, right? And then you look in front, so we know it's either up and up or down and down. And then you look in front, is it going to be flipped upside down? No, right? This is positive, so it's like a smiley face parabola. So we say our end behavior is up, and then hopefully you would be able to do as x approaches positive infinity. Where's my function approaching? Positive infinity, very good. You guys are going to do good in calculus next year. And then as x approaches negative infinity, our function is approaching. Good, awesome. Okay, good. And now the max number of turning points this could have is how many? Isn't it always one less than the degree? 7. So we could have something that looks like this. It turns once, turns twice, 3 times, 4, 5, 6, and wait, here, let's see, 1, 2, 3, 4, 5, there's 6, and then 7. Now it couldn't turn any more than that, or else wouldn't it not be the same end behavior? Does everybody understand that? It doesn't mean there definitely is 7 turning points, there could be less, but at most 7. Does that make sense from last time, everybody? Do we have questions on that? If you say no, then I believe you. So yes or no, do I need to clarify anything? I would love to. Yes. Great question. So that's why we learn this, is because sometimes your calculator won't graph these higher ones very good. So you could try graphing it, and if you can see it, then you could use it. But there are times when our calculator with such high degrees it gets crazy and it doesn't graph it very good. Did you try graphing this one? And what did it look like? Just curious. And it could only have one turn. Yes, it looked probably skew opposite, and it could. It just only has at most 7. Does that make sense, everybody? Yeah, great question, Amelia. Thank you. Okay, so looking over here, it's odd, right? So it has odd, opposite end behavior. Now you look in front, is it negative or positive? Negative, so it's like a negative line. The end behavior will work the same because that's also odd and that's negative. So our end behavior is up and down. I'm not going to go through the calculus notation on that one. And then what's the max number of turning points this could have? 4. Does it necessarily have 4? No, it could have less, but it could have up to 4. That's it, right? Yeah, most. Yeah, so it could have up to 4 turning points. No more than that, but it could have less. Yeah. Okay, you guys, is this making sense from last time? When we first saw it, maybe a little hard, but is it feeling a little easier hearing it again today? Okay, that's what we like to hear. All right, on your whiteboards, do this problem. Let's make sure we understand this from last time before we move on. So in a group, talk, help each other out. It says, what is the degree of a polynomial function with the following inputs and outputs? You'd ask yourself, what are inputs? Inputs are x values we put into a function, right? Outputs are what comes out when you plug something in. So we have some set of inputs and outputs. What is the degree? Can anyone remember from last time how we could possibly find that out? Taking what? Yeah. The differences of the x's or the y's. The y values, you're right. And do we need to check one thing first? Are my x values changing by the same amount each time? Yes, so we can do this. Go, tell me the degree. Okay, guys, so most of you got it right. I think there's one misunderstanding, and that's okay because that's why we're doing this. You took differences, and you took differences of your y values. Was it the same the first time? No. Nope. So you took differences of those values, and the second time the differences came out to be what? -4, -4, -4. So you would say, okay, it took 2 differences to get there. So it's degree 2. Does that make sense? We don't use, we're not going to use that number. It's just because they're the same, we know that it took 1 difference, 2 difference, so it's degree 2. Way to go. So we're comfortable with what we learned in 2-1, which is great. And today is 2-2. As you notice, it's a shorter worksheet because it's a shorter day. A lot of good things to learn. If you want to take a picture of this with your phone, absolutely please do. Okay? So today is 2-2. Remember what I'm talking about is blank, because I've already lost my voice and all around Oh, let me get out of your way. Okay, so the first thing we're going to do is we're going to talk about even and odd functions, and then we're going to later do adding and subtracting and multiplying functions, which will be just a good review. You should all be able to do that. So we're mostly going to spend most of our time on even and odd functions, which really isn't too bad, but you have to be really good at algebra. Now, fun fact for you, this is a true fact. Most people fail calculus 1, not because of calculus, but because of algebra. Pinky promise. And I love algebra. And so, yeah, but what I'm saying is, I promise you, you ask the calculus teachers, why do people fail calculus? It's not because the calculus part's hard. It's because the people's algebra is not good, so then they can't do the problems. Anyways, so today we're going to be dealing with some algebra. So, some functions can be classified as even or odd. Not all functions are even or odd. Some are neither. But functions can be classified as even, odd, or neither. You can determine whether a function is even or odd by looking at its graph or using algebra. So we're going to kind of do both. So an even function, you guys, an even function is a function f such that f of negative x is equal to f of x. And I'll explain that in just a second. The graph of an even function is symmetric across the y-axis. So that's the first thing you could do. You can graph it, look, for example, this picture right here. Do you see how this y-axis, the parabola, is symmetric across the y-axis? This would be considered even. Now I want you to notice something. So that's how we can check it graphically. If we look at it, if it is symmetric across the y-axis, we can say, yes, it's even. However, I might ask you on a test, can you show me that it's even for sure by algebra? And this is how we would do that. Now look up here. Do you see how these points match up if you reflect them? Yeah? Well, think about it. I'm going to scroll up so some people in the back can see this. This point right here is at over x up f of x, right? Isn't that how we graph points over x up y? So this is over x up f of x. Well, if I was to plug in negative x, that same distance but in the negative, aren't we still going to get positive f of x? If I plug in negative x into my function, you're going to still get positive f of x. So that's how we'll check it algebraically. I'll give you the function, say check it algebraically. You'll simply plug in negative x wherever there's an x, and if you simplify it and it comes out to be the same thing that you started with, that same f of x, you know for sure it's even. Does that kind of make sense? We'll practice that in just a second. So that's what an even function is. It's symmetric across the y-axis, and if we were to plug in negative x into our function and we get f of x again, then it's also even algebraically. Odd function. An odd function is a function f such that f of negative x, if we were to plug in negative x, it will equal negative f of x. I'll explain that part in a minute. The graph of an odd function is symmetric about the origin. So what that really means is it's symmetric about the origin really means if we take this, we reflect it across y first, and then reflect it across x, then it's symmetric. So if we take it, flip it across y, then flip it across x, then that would make it odd, okay? So how we would check this algebraically is, notice, this point and this point, if we were to reflect this point across the y and then across the x, do you see how it would match up? Yes? Now if I plug in negative x, so if I go over positive x, I'll get f of x. If I plug in negative x, I'm going to get negative f of x. So that's how you can check it algebraically. If you plug in negative x into the function and you get the opposite, negative f of x, then it's considered odd. Now, it'll make more sense once we do some slow examples. Are you guys ready for that? Awesome. Here we go. First example, it says, determine whether the function f of x is equal to x to the fourth minus 4x squared plus 2 is even, odd, or neither by graphing. So take your graphing calculators out. Let's graph that. So I'm going to grab my graphing calculator, and I'm going to graph it as well. You go to y equals, type it in. You hit graph. Are we all there? Do we all have it graphed on our graphing calculator? Okay. Okay, we graph it, and we have something that looks, I gotta try to draw this pretty symmetric. Something that looks like this, right? So looking at it, if we're gonna check if this is even by graphing, we would see, and I didn't draw that very good, see, it's really hard to freehand it. But if it is symmetric, that is not symmetric, the way I drew it was terrible. But if it was symmetric, if we folded it across the y-axis and it's the same, then we know it's even. I drew that terribly, very terribly. Freehanding it's hard, I should have done it. Does everybody understand how you can check it from graphing? Pretty easy, right? Now, algebraically, a lot of times it's better than graphing because sometimes your calculator is going to be a crazy mess. And that's when we would check by algebra. So let's check if that is truly even. Okay, so what we're going to do is say, okay, I have a function f of x. I have f of x is equal to x to the fourth minus 4x squared plus 2. We want to know what the function is going to be if we plug in a negative x instead of x. So what I'm doing is I'm taking and finding what's f as negative x. Now if I said f of 2, wouldn't you just put a 2 wherever there's an x, guys? So what we're doing is we're replacing our x's with negative x. Does everybody understand? If not, say, no, Miss Christensen, because I've had a lot of complaints that, oh, it's too fast and hard, but every time I say, does that make sense, you all say yes. So do I need to explain that again? We plugged a 2 in. If I said find f of 2, wouldn't we put a 2 in wherever there's an x? Yeah. So if I say find f of negative x, aren't I saying what's my function at negative x? When we substitute in negative x. Whenever we make a substitution, we put a parenthesis. So I'm going to have negative x to the fourth minus 4 times negative x squared. Questions on my substitution so far? And then plus 2. And now we're going to go ahead and simplify that down just to see where we're going to end up here. So let's think about this. Now let's use our algebra skills. Isn't this like negative 1x to the fourth? And this is like negative 1x squared. So if we have negative 1 to the fourth, isn't that going to be positive 1? Negative 1 to the fourth is positive 1, right? Negative 1 times negative 1 times negative 1 times negative 1. Positive 1. Is anything to the even degree positive? Yes or no? Okay. So we have 1x to the fourth. Does everybody understand how negative x to the fourth simplifies to be x to the fourth?
So we plug in
yeah, I just put a negative 1 in there because that's technically what we're looking at, right? Yes. And then we have our negative 4 still. And then we're raising negative 1 to the second power. Isn't that positive 1? And then we have now positive x squared. And then we have our plus 2. Now let's look at that function. Did that come out to be the exact same thing as f of x? Yes. And that's what happens when it's even. When we plug in negative x, we get that same f of x out. You see how algebraically I can check it? Yeah. Okay. Do you have questions? Yes?
You always plug in negative x?
Yes. Great question. Any others? Okay. Let's do another one. A little bit harder, but we can do it. We're going to have to be really good at algebra. This is pre-calculus level. I have to make sure you're ready for calculus. I don't want you to go on and fail calculus. So here we go. It says determine whether this function is even, odd, or neither algebraically. So our original function is g of x is equal to 1 over x cubed plus x. We check it algebraically by saying, okay, what happens when we plug in negative x? So I want to know what's g of negative x. Now remember, that just means you're simply substituting in negative x wherever there's an x. So we still have a 1 on top. On bottom, we're going to have negative x cubed. And then we have plus negative x. Now I just substituted in negative x. So I'm going to give you a second. Do we have questions on that? Okay, let's now simplify it. On top we have a 1. On bottom, isn't negative x cubed negative x cubed? Because isn't negative 1 cubed negative 1 times negative 1 times negative 1, which is negative 1? So we have a negative x cubed here. Do we have questions on why I want negative x cubed? And then we have plus negative x, so isn't that minus x? All right, now I want to say, well, this is where a lot of people kind of struggle. So I want you to pay attention to one thing here. If, I want to give myself some room, if you remember back to factoring, if I had negative 2x minus 2, and I said, let's factor this. If there's a negative in front, don't we always factor out that negative? Yeah, right? So then we divide each by negative 2. So that would make this positive x plus 1, right? You see how we have a negative in front here? Let's factor that out. So on top we have a 1. On bottom we're going to factor out negative 1. So now let's go back. Do you see why I'm factoring out negative 1? Because I have a negative in front? I wouldn't do that unless I had a negative in front. So I go back, divide each term by negative 1. So that's going to leave me with positive x cubed plus x. Yeah? So really, we're looking at, now negative 1 times all that stuff, let's just throw that negative in front. So we have 1 over x cubed plus x. Now that is what we had when we plugged in negative x. Because I just pulled this negative 1 out in front here. Right? Or is anybody lost? I just pulled it out in front. Because negative 1, we can just pull out in front here. So our original function was 1 over x cubed plus x. So don't we have negative f of x now that we plugged in negative x? Don't we have the negative function? Yeah, so it is odd. Questions? Hey, are you sure? I'm taking your word that you don't if you don't ask. Great question, because we know odd functions, if we plug in negative x, our function will come out the opposite of f of x, negative f of x, negative of the original. Okay, all right, try 1 through 7. Try it by yourself for a second, and then we'll go over a few together. But why not give it a try by yourself for a second, see if you can do it, and then we'll go over some of those together. You can write on your whiteboard and then just put your answer if you want on your paper. I'm fine with that. There's not a whole lot of room there. Does that work? Okay, awesome. You guys are great. When I did my worksheet, I did number 2 wrong, and I did it algebraically, so I don't know where I made the error. Let's go through it. The reason, so if you graph it, you can see if you graph it that it is even. But on a test, we need to be able to do it algebraically in case I say to you, show me that this is even using algebra. This group's done it. So let's go through this just to make sure that we're good. Now notice a couple things here. So we have g of x, I'm doing number 2 with you algebraically. And the reason we're doing it algebraically is because I might say to you, show me this algebraically. So I'm plugging in a negative x wherever there's an x, and then we'll simplify it and see where we're at. So notice how we have a negative in front and a negative in front here when I plug in negative x. So I'm going to rewrite this. I'm going to factor that negative out, because if we have a negative in front, we'll factor it out. So then divide each term by negative 1. So left is positive x minus 1, right? Everybody following me? I want to make sure we can do it algebraically. And we have plus absolute value. I'm factoring out -1, divide by -1. So left is x plus 1. Now, because these are multiplied, we can split these apart and write it as the absolute value of -1 times by the absolute value of x minus 1. Do you see how I split these apart?
Yeah.
And then I'm making these big so that we don't get confused with parentheses. So we have absolute value of -1 times absolute value of x plus 1. Continuing to simplify, absolute value means positive. So we have absolute value of -1, which is 1. So don't we have just absolute value of x minus 1? Yeah? And then we have plus the absolute value of -1, which is positive 1, x plus 1. Comparing that to the original function, isn't it the exact same? Yes, right? So that's how we know for sure it's even, algebraically. And I would make you show your work. That's one thing in secondary mastery honors. It's big into showing work. Questions? Okay. So if these would have both been negative, then we would have had negative f of x, and that would have been odd. Okay. Do you want me to do number 6 with you, or do you want to do it yourself? Do it with you. All right, so we're going to test algebraically if it's even, odd, or neither. So we do that by plugging in -x. We have 2 raised to the -x minus 2, and then we have our -x, and are we substituting in -x right there? Does everybody see what I'm doing? Substituting in -x wherever there's an x. And then that's all over 2. So we have 2 to the -x still. And then minus 2 to the positive x, right? A negative minus a negative is positive. Is everybody comfortable? All over 2. So looking at that, I'm going to look back up here and be really careful, because some people might say, oh, well, that's the same, but we've got to be careful, because look at the original function. They put the positive x first, so let's rewrite it in the same order. Won't that be -2 raised to the x, guys? If we were to write it in the same order they have it up here. So -2 raised to the x, and then plus 2 raised to the -x, all over 2. And then, remember, if you have a negative in front, we would factor out a negative. You see how I'm reordering it in the same order, everybody? I'm reordering it so that this is in front, the positive x, because in the original function, that's how they ordered it, so that we can compare it accurately. So now I have a negative in front, so I'm going to factor out, come on, that -1. I'm going to factor out a -1. So then I'm going to go back, divide each term by -1. So we have a 2, positive 2 raised to the x, and then positive 2 divided by so this is going to become a negative, right? Technically, we're actually taking positive 1 divided by -1. So it's going to be minus, do you see why it's minus? Okay, minus 2 raised to the -x, and then that's all over 2. The original function, tell me what it was again. It was 2 raised to the positive x minus 2 raised to the -x, all over 2? Yeah. So let's compare these things. Oh, isn't this the negative original f of x? Yeah. Yes, so it would be odd. Now, I just took a little bit of very careful algebra. Are we all okay? Okay. Okay, so let's do number 7 together. So it says, can you determine whether the product of any 2 odd functions is even, odd, or neither? So I just chose an example. I said, okay, so the product of any 2 odd functions. So I went x cubed times x cubed. That's x to the 6, right? Everybody? But then, so that's the product of 2 odds. but I want to make sure, it looks like it's going to be even, but I'm going to make sure. So I'm going to plug in negative x, wherever there's an x, into my function to make sure. So I'm plugging in negative x to the 6. Isn't that x to the 6? Wasn't it the same as our original function? So the product of any two odds will come out to be even. There's other ways you could have shown that, but that was just how I showed it. I took the product of 2 and then I made absolute sure by plugging in negative x, because that's how we test if it's going to come out even or odd. Okay. All right, and so are we doing okay with even and odd functions? Can we move on to the last part, and then the rest of the time will be yours to hopefully get as much done of this in class as possible. Okay, so now we're just going to be simplifying expressions, and then I'm just going to remind us how to name it by degree and number of terms, because we will have a quiz next week, and I'll talk about that next time, but let's go through this. So we're going to simplify this. Notice, guys, this is subtraction, and this is addition. A lot of people get confused. They'll see parentheses and just start multiplying things. Don't do that. This is simply combining like terms, but we've got to be careful about a few things here. Now, looking at this piece, we don't need to do anything with it to simplify it. That's just negative x minus 3. But looking at this piece, that's like having a negative 1 in front, right? So we would distribute that negative through. So that's going to be negative 2x squared minus 4x's plus 5.
Wait, what number?
This is just an example for you. I want to leave the others for you to practice. And then right here, we just have a plus sign, so we don't need to do anything. Minus x squared minus 4. And then you're combining like terms, right? This isn't hopefully super new for you. Negative 2x squared minus 1x squared is negative 3x squared. Negative 1x minus 4x's is negative 5x's. So I'm just combining like terms. Negative 3 plus 5 minus 4. So negative 3 plus 5 is positive 2, right? Minus 2 is negative 2. So I simplified it. Is everybody comfortable with simplifying? Now let's practice what we learned the other day. Let's name it by degree and number of terms. We look at the highest degree. So this is a quadratic. And there's 3 terms. 1, 2, 3. So that's a trinomial. Even though on your paper it doesn't say name it, you're right, it doesn't. I'm just reviewing. Hitting 2 birds with 1 stone. Okay, let's do another one. Looking at this, it says simplify. Wouldn't we multiply before we subtract and add things? So we would double distribute here. We'll distribute x through. So we would get negative x cubed, right? And then plus 3x squared minus 4x's. We would distribute that positive 2 through. So we have, I'm going to just put it under here, why not? Minus 2x squared, right? Plus 6x's minus 8. Let's combine like terms here. So we have a negative x cubed, no other x cubes. Positive 3x squared minus 2x squared is 1x squared, right? Negative 4x's plus 6x's is 2x's. Then we have minus 8. Now we can't forget that we have this minus all that stuff. So that's like a negative 1. We will distribute that through. So we have minus x minus 4. Combining like terms, negative x cubed plus x squared. 2x's minus 1x's is 1x. Negative 8 minus 4. Yep. So I'm just simplifying it, but you got to be really careful. We really do expect you to just be accurate in something this simple, because it is pretty simple for you guys. Let's name it by degree and number of terms. Degree 3, so it's cubic. 1, 2, 3, 4 terms. So it's a cubic polynomial of 4 terms. No special name for 4 terms. Okay, if you saw something like this, do you want me to go through it, or do you want to do good? I don't want to stand up here and waste your time. What would you like, class? Let's do it. All right, I like that. So we have 2x times negative 3x, which is negative 6x squared, right? 2x times positive 2y's is, and it's positive 4xy's, right? Questions? Negative y times negative 3x, positive 3xy's. Negative y times positive 2y would be negative 2y squared. Now we'll reorder it in standard form and combine like terms. We have negative 6x squareds, no other x squareds. We have minus 2y squareds, can't combine it with x squareds. And then we have 4xy's plus 3xy's, which is 7xy's. Now we'll name it by degree and number of terms. Quadratic trinomial, right?
Yeah.
Golden. Okay. When you see something like this, do you want me to go through it or do you know what you're doing? Let's do this one. Okay. Now, Gil, take my suggestion and you'll get these right every time. If you're multiplying, now guys, these are 3 binomials being multiplied. Now listen so that you're not like, you just heard, like you understand what I said. Binomials have 2 terms, right? So we have 1, 2, 3 binomials being multiplied. If that's true, if you ever have that, multiply 2 of them first, combine all like terms, and then multiply in the third one. You will not miss anything if you do that. If you start multiplying and trying, you're going to miss stuff. So I'm just going to ignore x minus 2 and distribute this through. X squared minus 3x plus x minus 3. Combine like terms first. X squared minus 2x minus 3. Does everybody see how I just multiplied those 2 together first? And now multiplying x minus 2. That way you don't miss anything. So we'll triple distribute. X cubed minus 2x squared minus 3x's minus 2x squared plus 4x's plus 6. So we've combined like terms. We have an x cubed, no other x cubes, negative 2x squared minus 2 more x squared is negative 4x squared plus 1x plus 6. So we would name it, it would be a cubic polynomial of 4 terms. Do we have questions? Everybody good? Just gotta be careful. Okay. Okay, so last thing, unless you want that one, but it says, number 17, this is on your worksheet. It says, is the difference of 2 polynomials, P1 and P2, always a polynomial? Explain. So, a lot of you, I notice, like, you kind of freak out when you get a problem that kind of causes you to think, and kind of, it takes a little bit deeper thinking, but you'll get better at it as we practice it. So it says, is the difference of 2 polynomials, P1 and P2. So we have a polynomial called P1. We have another polynomial called P2. It says, is the difference, doesn't difference mean subtraction? If the difference of 2, is the difference of 2 polynomials always a polynomial? Yes, right? If we just are combining like terms. If we took x plus 2 minus 3x plus 5, oh, that's a horrible 5. Isn't it going to simplify? We're just going to combine like terms. Aren't we still going to get a polynomial? Yes. Even if we get, let's say we did x plus 2 minus x plus 2. That's going to be 0, right? Technically, that's a polynomial. Aren't polynomials, don't we have a name called a constant monomial? That means a constant and 1 term. Technically a polynomial. Does that make sense, everybody? So make sure if you have something that you're like, I have no idea what that's talking about, think about it in pieces like I kind of helped you think through it just barely, okay? Now, does anyone remember what closed means? If I said, is this closed? So this is an example of closed. If I said, I don't know how I would word it. Is the difference of 2 polynomials closed? You would say, yes, because if you subtract 2 polynomials, you get a polynomial. Yes, so it's still a polynomial, so that would make it closed. So if I said to you, If I add two polynomials, is it closed? You would say yes, because if you add two polynomials, don't you still get a polynomial? Yes. Okay. Okay, I don't know, you guys struggled with this one a lot more than I thought you would on when we were doing like the quadratic stuff. This isn't a quadratics, but I'm just a little bit, I want to help you if you need it. So let's read this. If a rectangle length is 12 feet longer than its width, and the width of the rectangle is given below, write a statement for perimeter and area. Would you know how to do that? Or do you want me to go through this and this will be my last example? It's up to you. I'm here to help you, but not waste your time. You want to go through it? Okay. So we have this picture. We have a length and a width. We're given that the length is 12 feet longer than the width. Here's our width, right? So if our length is 12 feet longer, when we take that x minus 5 and add 12 to get the length. So really, our length is x, right? X plus 7. So now it says, write a statement for perimeter. Isn't perimeter adding up the entire outside? So we can do this two different ways. We can do it the easy way or the long way. I don't care how you do it. We could go x minus 5 plus x minus 5 plus x minus 7, x plus 7 plus x plus 7, right? Or we could say we have two x plus 7s, right? And this is really at an honors level how you should be thinking. We have two x plus 7s, right? Plus 2x minus 5. Isn't that true? There's the statement for perimeter. That's good enough. That's what it's, so area, write a statement for area. Area of a rectangle is length times width. Won't that be x minus 5 or x? It doesn't matter order. So x minus 5 times x plus 7. Have we now written a statement for area? We've accomplished our goal. Does that make sense, everybody? Okay. All right, finish the worksheets. Problem 26 and 27 are for advanced thinkers. So attempt them. If you can't do it, then you don't need to get too worked up about it. And the reason I didn't post problem number 30 yet is because my thing has been having technical difficulties. But I really will post problem number 30 from last time if you're interested. Yes.